All right. So, welcome everyone. We're going to have two talks today. So, John's going to go first, I'm going to go second. And yeah, then we'll have a bit of a discussion afterwards. We'll probably go for food and drink. And welcome everyone new as well. Great to see a few new faces. And that's it.
Yeah, thanks for coming, everyone. Come on. Working perfectly until I start talking, and then it's
5 is grayed out.
Oh, you know what? I'm looking at Zoom. I'm not looking at there we go. Now we're in. Okay. So let me start with the standard questions. My name is Jonathan. I have been a software developer for 20-something years, and most of that has been in like financial applications, mostly high-frequency trading. And as you saw, the title of the talk is going to be real-world functional programming in financial applications. And that might sound like it's kind of a vague umbrella concept for me to just get up here and tell a bunch of old war stories. And that is correct. That's exactly what I'm going to do. But I hope it will be interesting nonetheless. And so I'm going to go through 3 different examples. The first one I've called the spreadsheet from hell. I'm going to talk about a project that I worked on to port C++ to Scala. And I'm going to lastly talk about the algorithmic crypto trader that I wrote myself. So the first one is a spreadsheet from hell. This is not the real spreadsheet because I was working for a company that is like extremely litigious and would kill me if I showed you the real one. But this is Adelide's idea of what a spreadsheet from hell might look like. So I was working at this place and I had a trader come to me with this insane spreadsheet that was like 30+ tabs, like complete spaghetti code between all of them. Absolutely insane. And he said, here's my new strategy, please implement it in a real programming language. So the real programming language we used at the time was C#. And so I ported it to that and it didn't work at all. It was like really slow. It was even slower than the Excel spreadsheet, which was already pretty bad. And so I wondered why this was, and I thought about it because in C# you've got an object-oriented paradigm, so you have all these different, objects that are doing their own thing internally, and you need some kind of way to get your messages moving back and forth between them, and that means you've got to worry about threading and synchronization and all that stuff. Whereas your Excel spreadsheet, you update a cell, and then the information just flows. It knows the relationships between all the cells, so it just kind of flows through nice and naturally, and it doesn't do any extraneous work. So what I did was port it to F# because I think it was fairly new at that time. This was like 15 years ago or something. And it worked great. So the performance was suddenly much, much better. And yeah, everyone was very happy.
Sorry, is this high frequency trading?
Yes, yeah.
Okay.
This particular application wasn't like what they call ultra high frequency trading, which is when you've got, FPGAs and that kind of thing involved. So it had to be fast, but not really fast. And that's a similar theme in my next example. So we have this, so this here is a diagram, it's a representation of the binomial pricing model. So we were trading options, and normally when you trade an option, you can use this equation called the Black-Scholes equation, which is just a nice normal analytical equation that you put your inputs in and get your outputs out. Nice and easy. Some options can't be priced that way, so you've got to do it with a numerical method like this one. And yeah, you can see that it's what we're doing is we're modeling at each point in time. We say the price can either go up or down with some probability, and then you just do that for as long as you want into the future to get a price. And so that's ordering squared, I think, in terms of performance, whereas in Black-Scholes is order 1. So yeah, it's quite computationally intensive. And we had this implemented in C++, and I wanted to use it in my Scala application. So I figured I'd just port it across. But we had a low latency requirement because when you're doing high frequency trading, even for the stuff that's not on an FPGA, we were still measuring latencies in like hundreds of microseconds. So
Sorry, what was again the reason for moving from C++ to Scala?
So I had another component that was already in Scala, and I needed to get this code into there. So I could have, like, figured out a way for my component to talk to their component, blah, blah, blah.
Not that C++ is slow.
No, no. But yeah, then you get into a whole bunch of politics. I didn't want to do that, so I was like, I'll just copy their code and rewrite it. Yeah.
Is it the hotspot, the hotspot, the JVM?
No, I didn't use, I don't remember exactly which JVM I used. Pretty sure it wasn't hotspot.
Oh, just like they have the thing where it like what's it called, where like it optimizes. It like memorizes like open JRE.
Yeah, I think it might have been OpenJRE that I used. Yeah, and it definitely wasn't hotspot because it performed like shit. And the culprit was autoboxing. So in the JVM, sometimes the platform will just decide you've got a value type. I'm just going to wrap that in a reference, carry that around for a while, and then unwrap it for no good reason. Especially when you've got something like this implemented in a functional programming paradigm, because there's absolutely no reason to be throwing references around. Everything can just calculate immutably, and yeah, you don't have to worry about memory management so much. So once I got rid of the autoboxing, which was a matter of using the correct Scala like functions and just kind of massaging it a little bit so that it didn't have any of these stupid JVM intermediate steps, then we actually got the performance to be 3 times slower than C++. And that's about as good as you can get in benchmarks between C++ and the JVM. So that was another sort of example that showed how useful and powerful functional programming can be. So the last example I want to show you is this algorithmic trader so this one I wrote myself. This was not me working for another company, so I can go into a bit more detail with this one. So yeah, once I was not working for someone else, I was like, okay, I'm going to try trading on my own. And the natural choice is to do crypto because there's no barrier to entry at all. If you want to trade traditional markets, you've got to pay them like 20 grand a year or something, decent access. And even then, if you don't have an FPGA, you still forget about it. So I wrote this from scratch in Scala. And if you ever get the opportunity to write a real practical application yourself that's going to make money, supposedly, without anyone looking over your shoulder and any annoying managers to deal with, then I highly recommend you do it. It's an incredibly satisfying experience. Oops, that's what I want. Yeah, so I wrote it with 100% functional paradigm because Scala is like a mixed language. You can write it imperative or object-oriented as well if you want, but you can do it purely functional if that's what you choose as well. And I use this reactive paradigm, which I'll go into in a bit more detail in another slide. And it worked perfectly as a platform. So there were no bugs. I didn't lose all my money because it threw it all away in the market because of some improper programming that I did, and it performed really well as well. Unfortunately, that's not the only thing you need to make money in the markets. So if anyone has a trading strategy that is always profitable in all market conditions, then let me know. Maybe we can work it out together. Yeah, there's a couple of to-dos that I have for this application. I would like to open source it one day. First, I just need to go through and remove all the ideas for strategies I had that were too embarrassing to share, and probably delete my private keys and API keys. And I'm also keen to port it to Haskell, because Haskell I've started experimenting with, but I haven't tried it on a real application yet. So I think it would be interesting to see how it compares to Scala when it comes to something like this that relies on a lot of libraries, which is one of the JVM's strengths, is that you have all these libraries ready for you to use. But that's probably a topic for another talk. So this is sort of like the architecture of how it would look if I were to present it in an object-oriented way. So at the bottom, you've got all your libraries. So it's all kind of, you've got this reactive / streams library at the bottom, powering everything. And then you've got, I think I use Swing for the UI, and it's just standard network libraries. You separate the strategy and the exchange logic because there are multiple different exchanges that you might want to trade on, and there are multiple different strategies that might want to run. So we've got our abstract interface here in the middle, so that any strategy can run on any exchange. And the typical flow of events will be that an event comes in, a message comes in from the network saying this is the new price of Bitcoin. Your exchange is going to translate that, send it to the UI so we can show it on the screen, and tell the strategy this is a new price, and the strategy will send back a message saying these are the new orders I want to put in. The exchange will translate that and send a message to the exchange itself. So when we do a reactive architecture, what we do is we implement the whole thing as a state machine, and we have a stream of events coming in from the UI, from the network, or from timers going off, and each one of those will, so we linearize. We put them all in a line, and one comes in after the other, and the state machine will iterate on each event. And each state will produce a number of side effects in the form of either updates to the UI, updates to the messages, or changes to the timers. It just so happens that the events and the outputs kind of match each other, but that's, I think, just chance. It doesn't have to be that way. You could add something without a UI and only a command line or something like that, and it would look a bit different. So I use this reactive programming library called monix.reactive. I originally wrote my own because there wasn't a good enough one around, but then this one popped up and I used it instead. It turned out to be better than what I wrote. So the concept is that you have observables and you have observers. So an observable is something that produces events, and an observer is something that can receive an event. And you have also a subject, which is both. So the idea is that you kind of chain all these together. So it even looks a little bit like an Excel spreadsheet. And that, an event that happens here will update a bunch of different things that flow through to get your outputs. So I want to show you some of the code. You guys will read that okay? Yeah. So if you're not familiar with Scala, it has a nice property, which is that you declare a class, and you can see here that we pass in all the variables. The declaration of the class doubles as the constructor definition. And all of these are like basically immutable private variables that are available inside that class. And then in the class definition, we can also create more private variables derived from the ones that we've passed in. The bit I want to show you is this around here. So this variable here is the event stream. So we're creating an observable from a bunch of other event streams, and then we're merging them all together. So this is a process of, like on the previous slide, you have multiple observables all coming into one subject. So the events that, I should mention this class that I'm showing you is a strategy. This is one of the many strategies that I tried that didn't work. So don't worry about how it actually works. It's not important. I mean, don't worry about what the actual strategy is. The implementation is interesting, but the idea is not. So this strategy cares about the client here is the exchange client, the exchange module. We care when we do a trade, and we care when the markets update. And the markets are the best bid and ask for Bitcoin in the market. We can call map on an event stream just like you can on a list or a vector in regular functional programming. So yeah, if a list or a vector is a group of items in space, events is kind of like a group of items in time. And you can use your map and your fold and your scan and your filter and all the standard functional programming functions in exactly the same way. So we do a map because we are only interested in the price we get the price and a volume for each market. We're discarding the volumes, and then we're saying distinct until changed, which is a nice handy function that just only emits an event when the value is actually changed from the last one. And then we merge them all together into one single event stream. And we take that event stream and we call scan on it, and we pass in a state, and then each event is going to call on next on that state. So this is just one little state machine that's inside the big state machine that is the whole application. And of those states, the only things we actually care about are quotes. A quote is like a term in finance for the price that we're willing to buy and sell at in the market. So we call a map on the states and we get our quotes out. And the last thing that we do is I have this concept called toggle quotes, because I've got a big red button in the UI, which is basically on and off. So right at the end, we apply this kind of like a filter that will pull our orders out if I turn it off and put them back in again when I turn it on. And so that if you remember, the client is the exchange module, and it has a function called quote, which is an observer. So we can pass our quotes event stream into that observer. And as far as this class is concerned, that's like a sink that the events go into, and it doesn't care what happens after that. But of course, the actual implementation of that client is its own state machine with its own subjects and observables inside that.
Is this still sort of inside the constructor, or is it incorrect to think of it as a constructor?
Yeah, actually, it is correct to think of it as a constructor, because this code will all get called when the strategy is constructed. Yeah. So it's, yeah.
And there's things you're mapping of it, are they kind of like streams, and you're doing like, it's like a lazy map, like or
yeah, so this is all sort of handled under the hood by the library. And there's actually a lot of complexity in there, because I never had to dive into it. Everything worked fine out of the box, but there you can tweak whether it's sort of like pushed by the observable or pulled by the observer, and you can really get really into the weeds with that stuff. So it's quite complex. Yeah, I'm not sure exactly what it does by default, but whatever it was, it worked fine for me. Yeah, maybe it's also nice to talk about this these private traits here. So a trait is like an interface in Scala, and you can make them private. So this trait and all its and all the classes that implement it are private just to this class. So every one of these classes that is also a state machine kind of has a concept like this of event, but these ones here are scoped only to this class, which means that each class can define an event and its own types of events and not interfere with each other at all. I think that's one thing that I find quite nice and elegant about Scala.
That's not very functional.
It's not.
Not very functional.
I'll have it scoped privately. Yeah. Maybe
doing
not.
like the inheritance. It's not inheritance.
That's how you do union types in Scala, right?
Yeah. Yeah.
Cool. So it's quite functional. I would say.
What's that?
It's quite functional, I would say.
Yeah.
Because you can pretty much do good algebraic data types there.
Yeah. Yeah, I was very, very strict on myself to only do it in a functional way. We can maybe also talk a little bit about the implementation of the state itself. So you've got like, this is sort of like the trait, the interface. So the only property a state needs to have is that it produces a quote, and we can call on next on it. And so pending state is what we start with. And you can see here the definition of quote is just that basically we don't want to quote anything yet. And on next is a bit more complicated, but once we start getting events from the market and the CMA thing, the exponential moving average, which is something we use to like smooth the prices that are coming in, we will then move to different state implementations. that will start calculating our bid and ask prices that we want to put in the market. Yeah, so that's the code. Yeah, so that's the end of that example. To finish off, I wanted to talk about some of the limitations of functional programming that I've found that have encountered in practice. The first and most important one is politics. So the biggest obstacle I had to doing functional programming in any company was, of course, all these other annoying people that I had to work with. So your managers will never let you do anything differently or use a new programming language because they're like, well, why are we doing this? Everything works fine the way it is, and we don't want to change anything because that's going to cost time and money. I also was surprised how much pushback I got from my fellow developers as well. Many of them don't want to learn anything new just because that's the kind of people they are. I did have one fellow tech lead tell me, listen, it's okay for you and me to do this functional programming stuff. Most of these guys, they won't get it, which I thought was elitist and very unfair. Yeah, well, going off on a little tangent. I did some work like teaching people programming who were total beginners, and the way they did it was teaching them, they started them out with JavaScript. That's great, JavaScript's really easy, they'll pick it up in no time. Well, the very first thing they had to implement was like a timer. So just every second there was a number on the page, it was 0, 1, 2, 3, 4. But every single one of them, their first try went 111, 111, 1,111, because they were adding strings and numbers. And if we had started them out with a strongly typed language, I think, you know, the compiler would have held their hand through that whole process, and they would have hopefully understood the concepts correctly. And so I think we should even go one step further and start people out with a really strict functional programming language, because the more strict it is on them in the beginning, the more they will learn and internalize the concepts. And once you've got all that stuff down, then you can go and write in Python or JavaScript, and you won't run into as much trouble because you understand the concepts properly. Tangent over. So the next limitation is performance. It's not to say that any functional programming that I've done has performed poorly, but it just won't. None of the languages that I've tried will match the best-in-class languages like C++ or Rust. Maybe there are some languages that I haven't tried that are better. All the ones that I've tried are like garbage collected, so that kicks you in the nuts straight away. There's no way you can compete with Rust if you're running a garbage collector all the time. So yeah, maybe one day I'll find a functional programming language that doesn't do garbage collection. It might be interesting to see how it goes.
There is a project from a Brazilian guy that is doing just that. Recently, I was sharing on Slack. It's really interesting. It's like based on some studies from the 80s, some some models, different models, like completely different model of computation. It's not von Neumann and stuff like that, so it's completely different. And he's implementing that in his testing, and it's like beats JVM or even Haskell. The Haskell compiler, I don't remember the name now, by far, like 30 times faster for multi-core.
Yeah.
Automatically parallelize the code, stuff like that. It's really interesting. Yeah. There's some guys like program, these guys from like heavy investors in the United States are following this guy already because he's really into something. It looks like.
Yeah, we'll drop the link up to do it.
Yeah. You guys will be very interested in seeing that.
I think this language, have you heard of a list called Stockflow?
No.
I think the idea was
Okay, cool. Yeah.
At least like the air conditioning.
Yeah, and the last thing I wanted to mention is language support. So you don't have to have a functional programming language to do functional programming. You can do it in C++ or Python or whatever you like. But when you do, sometimes the language itself will fight you. So I've been doing a fair bit of Python programming recently, and I'm a real really determined to do everything in a functional programming way. But when I'm writing Python, sometimes I just have to say, fuck it, it's too hard. I'm just going to put another field into this dictionary because I don't want to sit here for another 4 hours trying to do it the right way. And the other one I had trouble with was Rust. So, for example, the built-in scan function in Rust has a mutable variable in the function signature, and it grinds my gears every time I see it. But like clearly, whoever implemented that didn't actually understand didn't understand what they were doing, and just had to was checking off a feature checklist or something. Yeah. So that's, I think, brings us to the end. Any questions?
There's a picture of Trump Dali as well.
No, that's a real picture.
So you shared earlier a picture of Investopedia by some algorithm. You said this was 15 years ago.
Yeah.
And you were implementing it by yourself. Do you think by now, 2023, this is standard somewhere on GitHub?
Almost, yeah, probably, yeah. I haven't looked because I think even 15 years ago it might have been standard because it's not a secret. I think, you know, it's the kind of thing that's been published in journals and so on. So
Yeah, but usually, yeah, true. But implementation, usually they don't share it.
yeah, I mean, yeah, I'd be surprised if it wasn't on GitHub. So yeah.
Are you going to change the name of the project before you open source it?
So the project is called BitCount.
Oh, I saw
that was
that.
funny. But
What was the other name as well? There was some point there. It was good kind and then dot and then something else.
That's something, man.
Yeah, rebate man.
rebate man, yes. So because that strategy was designed to take advantage of the rebates that market makers get on certain things.
Okay.
Yeah.
Oh, interesting.
Still didn't work.
So I don't have much experience with Scala, but is one of the strengths that it can be like it's very easy to run stuff on a cluster, like distributed? Maybe I'm thinking of that.
Yeah, I'm not sure actually. I need to try that.
Okay. Have you done anything distributed in it or not?
No, all this high frequency trading stuff, you don't want to distribute it because you've got latency between your different throughout your cluster. So everything runs on one machine, ideally on one chip. If you're
Pretty monolithic, right?
What's that?
Pretty monolithic.
Yeah,
right?
yeah. Very.
We're using the you use Scala native. How does it compare to the Java Scala? To JVM Scala?
No, I haven't used that. Thank you. Yeah, I think it worked fine out of the box for the purposes of a crypto exchange. I mean, crypto exchanges, I was talking earlier about, you know, on traditional finance, we measured things in hundreds of microseconds, and that was the slow stuff. Like the really fast stuff they were doing using FPGAs, and now they actually manufacture their own chips. So yeah, and on crypto, on the other hand, even the good exchanges would sometimes like just totally fall over, and they would be sending you price updates that were a minute or more out of date, which is, yeah. I mean, when you're dealing with that kind of thing, there's no point shaving off 100 microseconds. Like, yeah.
Did you do much unit testing for it?
Oh yeah, I wrote I think the last time I checked, there were nearly 800 unit tests. Yeah, I followed quite a strict TDD regimen as well. Yeah, I mean that was one thing. I mean, it's not related to functional programming per se, but that's one thing that really saved my ass. And finance is, you know, it's quite a high pressure environment, and you've got these type A personalities breathing down your neck all the time. They want everything yesterday, but God forbid that it should break in production because you're out $100,000 or $1 million if something goes wrong. So test-driven development is really the only way that you can get yourself out of that hole to deliver things quickly and without any bugs.
That's nice.
Do you really like be trading on-chain protocols?
No. Like, so this project that's sort of been retired for a few years now. I think 2018 was the last time I was really, 2018, 2019. And I think a lot of that, like Uniswap sort of stuff was starting up around then, but it was still early days. And I was really just focused on the centralized exchanges, but I definitely had it in my head that there's probably some quite interesting opportunities with the on-chain stuff for sure. And that requires a whole different paradigm way of looking at things, because you've really got to be, you know, have your nose right in the mempool and figuring stuff out like that. Be really interesting, I'm sure.
All right. Over there.
What am I going to do?
This is not a weird flex, it's just so that the cursor, like the mouse is really good at that.
Oh, I thought you were gonna read it.
That's right, this one's for you. That's right.